Hi, it's DK. Today we're going to talk a little bit about number systems, just expanding on the things that Professor Mayhew has already told you, right? So what do we have here? All right, so what we've got is we've got the decimal number system. Okay, decimal number system consists of decimal number system consists of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's so those are the symbols that make up the 10 symbols for a decimal number system. All right, so for instance, if we are going to convert the number 1024 into decimals, and put them into the slots, what we have is 4 right here, right? 4 times 1, which is 4 times 10 to the 0th power. Then we have your 2 times 10 to the 1st power. Then you have your 100s column over here, which is 0, and then your 1000s column right in here, which is 1. So that's your 1024. All right. And the way you add that, of course, is 1 times 10 to the 3rd, which is over here, 0 times 10 to the 2nd, which is here, and 2 times 10 to the 1st power, which is 2 times 10, right over there, and 4 times 10 to the 0th power, which, by the way, 10 to the 0th power is equal to 1. So that's 4 times 1. All right? Okay, so how about the binary set? All right, so the binary set is such that you have two symbols, 0 and, sorry about that again. You have two symbols. You have your symbol 0 and you have your symbol 1. Okay, and so your binary system will look like, so the binary number that you'll have starts at 2 to the 0th power, that you'll see on the right here, and then 2 to the 1st, 2 to the 2nd, 2 to the 3rd, and so on. Of course, 2 to the 3rd is 8, 2 to the 4th is 16, 32, 64, 128 for 2 to the 7th. So, what if we want to convert a binary number 1010? Well, we'll just put them into our little boxes, 1010. So that would be 0 times 2 to the 0th power, all right, which is this guy right here, because 2 to the 0th power is equal to 1. 1 times 2 to the 1st power, which is 1 times 2. 0 times 2 to the 2nd power, which is 0 times 4. And then 1 times 10 to the 3rd power, which is 1 times 8. And that's 10 in your decimal system. So what about something like this, What about something like this? 1, 1, 1, 1, 1, 1. Okay, 8 ones. In that case, we can just stick everything in here, right? So this will be the 2 to the 0th power, and then this guy here will be 2 to the 7th power out here. Okay, and then you can add them up. And what that'll end up happening when you add them up, the result will be 255 in decimal. Alrighty, so let's go for the next slide. How about the octal set? All right, so the octal set consists of 8 symbols, 0, 1, 2, 3, 4, 5, 6, 7. All right, there's 8 symbols there. And again, we're going to take a look at what we have here. Okay, we're going to take a look at our number placement. So we're going to have 8 to the 0th power, since octal is base 8. 8 to the 1st power, 2nd power, and so on. So if we want to convert 121 in octal, all right, then you'll just put them in here, 121, there we go. So it'll be 1 times 8 to the 0th power. 8 to the 0th power is equal to 1. So that'll be this guy here, 1 times 1. Then you have 2 times 8 to the 1st power, which is 2 times 8, which is right there. And then you're going to add that to 1 times 8 to the 2nd power. 8 to the 2nd power is 64, so it's 1 times 64. You're going to add up all of these guys in that equation, and that's going to give you 81 decimal. Hexadecimal. All right, hexadecimal is base 16, right? So there's going to be 16 symbols. You got these 16 symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A, B, C, D, E, F, okay? So A is the equivalent of binary, decimal 10 rather. B is the equivalent of decimal 11. F is the equivalent of decimal 15, all right? Okay. So if we have FF, all right, by the way, you can fill in everything here as 0, 0, 0, 0, 0, 0, and then FF, okay? The least significant digit, because it's the least significant digit, okay? The least significant part will be F times 16 to the 0th power. 16 to the 0th power is equal to 1. We know that F is 15, so that's 15 times 1, plus you have F times 16 to the 1st power. You know what F is. F is equal to 15. So 15 times 16 to the 1st power. You add these two numbers together, and that'll give you 255 in decimal. Hey, this is kind of cool, actually. It turns out that, look, if you represent FF in binary, okay, so I'm going to expand out the right-handmost F, and that's going to be 1, 1, 1, 1, okay, in binary. And then here, for that second digit, second to the right, that's also going to be 1, 1, 1, 1, all right? So it turns out that FF is the same thing as 1, 1, 1, 1, 1, 1, 1, 1 in binary, base 2, this is base 16, and that's also equal to 255. It's kind of a cool little conversion. So what you can do is you take each symbol of a hexadecimal and convert it to binary straight up, which is kind of cool. So how's that done? All right, so the way that's done is through this number system, okay? It's a number system in a nutshell. You see, you got the binary basis right up. Whoops. You got the, sorry about that. You got the binary basis right over here on the left-hand column, right? Base 2, right? And then you got your decimal base, right? So of course 0 is equal to 0, and then 0, 1 is equal to 1, and 1, 0 is equal to 2, etc. Okay. For hexadecimal, you have the symbol set 0 through 15, and look, right down here. Okay, look at this thing. Hey, check it out. All right, when it's hexadecimal F, it's the same thing as 1, 1, 1, 1. All right, so that's the basis of the little conversion that we did on the previous slide. Octal is kind of interesting. Okay, so you got your 8 symbols here, right? 0 through 7. That's 8 symbols. But look at this thing. When you have an octal 7, when you have an octal 7 right in here, that's the same thing as 1, 1, 1, 1. All right, so that's kind of a cool thing. So if you have an octal, let's say you have an octal number. Let's say you have 121 base 8 octal, and you want to convert it to a binary. So typically, binary would be, let's see, 1 is in the octal base set. Okay, 1 is still equal to 1, so you're going to use 0, 0, 1. Okay, that's the first symbol. And then the second symbol is 2, so it's 0, 0, 0, 1, 0, 1, 0. Okay, because 0, 1, 0 is the number 2 here in octal. And then 1 again is 0, 1, 0, 0, 1. All right, so 121 in octal is the same thing as 0, 0, 1, 0, 1, 0, 0, 0, 1 octal, binary rather. All right, great. So let's continue on. Okay, so here's an example of binary decimal to binary. All right, so what we're going to do here is I'm going to stop here on this video, this part A of this video, and I'm going to pick it up here when we convert from decimal to binary. We're going to do all these conversions, okay, here in a little bit. But for right now, I'm going to stop right here, tell you that we're going to take this up in part 2 of the number systems video, and I'll see you then.